Good morning, dear students. My name is Farhan Mazhar, and the subject today we are studying is Cambridge O Levels uh, Physics 5054. So, this video is about the revision of the new topic which is added into the syllabus of the Cambridge, and the name of the topic is the space physics. And for this purpose, we are going to revise that topic. I have already made some videos on this topic, and I have made videos from two different books. And today, and I'm going to make this video to revise this new topic, and all the material, all the, you can say, the literature which I'm using, that I have taken from the website Save My Exam. And the author's name of this literature is Cathy. And in this literature, you will see we have given her the credit of this literature. This literature is not written by me. This literature is written by Miss Cathy, and her name will show up in this literature. Okay, so the solar system. So the objects, the first thing which we are going to revise is the objects in the solar system. The sun lies at the center of the solar system. The sun is a star which make up over 99% of the mass of the solar system. There are 8 planets and an unknown number of dwarf planets which orbit the sun. The gravitational field around planets is strong enough to have pulled in all nearby objects, with the exception of natural satellites. The gravitational field around a dwarf planet is not strong enough to have pulled it nearby objects. There are 4 rocky planets: Mercury, Venus, Earth, and Mars. So remember these things. There are 4 rocky planets: Mercury, Venus, Earth, and Mars. There are 4 gas planets, and their names are Jupiter, Saturn, Uranus, and Neptune. Some planets have moons which orbit them. Moons are an example of natural satellites. Artificial satellites are man-made and can orbit any object in space. The International Space Station, ISS, orbits the Earth and is an example of an artificial satellite. Asteroids and comets also orbit the sun. An asteroid is a small rocky object which orbits the sun. The asteroid belt lies between Mars and Jupiter. Comets are made of dust and ice and orbit the sun in a different orbit to those of planets. The ice melts when the comet approaches the sun and forms the comet's tail. So here we have the objects in our solar system. So you can see here we have the sun, then we have Mercury, Venus, Earth, and Mars. So these 4 planets, they are rocky planets: Jupiter, Saturn, Uranus, and Neptune, and they are gas planets. And Pluto, that is a dwarf planet. So here you can see we have artificial satellites. The moon around the Earth is a natural satellite. So between the Mars and the Jupiter, we have this asteroid belt. So I hope you understand this figure, and this will help you to understand this, revise this topic. So we have the exam tip. You need to know the order of the 8 planets in the solar system. The following mnemonic gives the first letter of each of the planets to help you recall them. And he says, my very excellent mother just served us noodles. My very excellent mother just served us noodles. So that makes you to remember the order, the names of the planets. So it represents Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. This mnemonic can also be Sometimes we call it, my very educated mother just served us nachos. So you can remember this sentence, my very excellent mother just served us noodles, or you can, my very educated mother just served us nachos. So by this mnemonic, you can remember the order and the exact names of the planets around the sun. Before Pluto was classified as a dwarf planet in 2006, my very excellent mother used to serve us 9 pizzas, and you can still use that one to remember the old solar system. So this is the exam tip. So the author of this literature is Katie. So the Katie has always been passionate about the science and completed a degree in astrophysics at Sheffield University. She decided that she wanted to inspire other young people, so moved to Bristol to complete a PGCE in secondary science. She particularly loves creating fun and absorbing materials to help students achieve their exam potential. So this literature, which we are using to revise the space physics, this is actually written by author Katie, not by me. I'm just using it. I have taken it from the Save My Exam. Our place in the space, our solar system, is just one small part of the Milky Way galaxy. So the name of our galaxy, in which the Earth is and our sun is Milky Way. There are billions of stars in the Milky Way galaxy. Some of these stars also have planets which orbit them. The universe is made up of many different galaxies. So here we have a photo, and let me show you. And it says this is the Milky Way, and we are here somewhere. The Earth is here in the Milky Way. Our solar system is just one out of potentially billions in our galactic neighborhood. The Milky Way, there are estimated to be more than 100 billion galaxies in the entire universe. 100 billion galaxies. Milky Way is one of them. Okay, so how the sun is formed, the formation of the sun from exam point of view, this question has been frequently asked in the Cambridge O-levels physics exam. Some you must have remember that in 2016 this question was asked, and this you should remember this answer also, how the sun is formed. The sun is formed from massive clouds of dust and gas in space. So the sun starts by a cloud of dust and gas in space. A cloud of dust and gas in space is called a nebula. So this is called nebula, the cloud of dust and gas. A nebula is a cloud of gas and dust in space. So image courtesy of the NASA. So, okay, the gravity pulled this cloud into a giant ball. Okay, due to the gravity, the dust and the cloud, they come close to each other. A giant ball is formed. The nebula collapses due to the gravity and begins to rotate. So the nebula starts to rotate. So then what happens? As the nebula collapsed, the center of the ball got very dense and hot and began to rotate. Eventually, nuclear fusion was able to begin, and a dense protostar was formed, which is our sun. Protostar, our sun. So when due to the gravity, the dust particles, the gas particles, they come very close to each other, then the nuclear fusion starts happening. And so when the nuclear fusion starts happening, so there is a lot of heat, there is a lot of light, and this is called the protostar. So our sun is formed. So we get equilibrium in the sun, equilibrium in the sun, in the stars or in the sun. Stars are held together by a delicate balance of inward and outward forces. You see, due to the high gravity, there is an inward force which is trying to collapse the star. And due to the nuclear fusion and the heat produced, there is an outward force which is trying to expand the star. These two forces are balanced with each other. So the equilibrium in stars are held together by a delicate balance of inwards and outward forces. One of these forces is the force of gravity. This is an attractive force which pulls the outer layers inwards. The other force is the force of pressure. This is an outward force which is exerted from the expanding hot gases inside the star. Equilibrium in stars. When the inward pull of gravity and the outward pressure acting on the star are equal, the star will be in equilibrium. So you can see here with the red colors, we have shown the outward pressure, and with the black color lines, we have shown the inward pull of the gravity. So the forces acting within a star, the center red circle represents the star's core, and the orange circle represents the star's outer layer. So there is an inward force of inward pull of the gravity, and there is an outward pressure due to the expanding hot gases, and they are when in balance with each other. So this is the equilibrium in the stars. If the temperature of a star increases, the outward pressure will also increase. This will cause the star to expand. If the temperature drops, because perhaps the rate of fusion has slowed, the outward pressure will also decrease. This will cause the stars to contract. So this literature is coming from the author Katie. This is not written by us. We have taken her literature and we are sharing with you. So fusion in the stars, actually very simple element, the most simple element, which is hydrogen. And when due to the gravity pull, they come close to each other, their fusion starts. So what is the fusion? Fusion is that when the nucleus of hydrogen and hydrogen come very close to each other, normally they are repelling each other. So when you overcome that repulsion force and you fuse them, their nuclei together, a large nucleus of helium is formed. This process is called fusion, and in this process a lot of energy, lot of heat is given out. All the naturally occurring elements apart from hydrogen have been formed by nuclear fusion in stars. Nuclear fusion occurs when two light nuclei collide at high speed and join to create a larger, heavier nucleus. When the universe was first formed 13.8 billion years ago, the only element present was hydrogen. If two hydrogen nuclei collide with enough energy, they will fuse into a helium nucleus. For example, the nuclei of two different isotopes of hydrogen, protium and tritium, can join to form a helium nucleus by the process of nuclear fusion. An example here in the diagram, you can see an example of the fusion of the protium and tritium to form helium. Protium is the isotope of hydrogen, hydrogen 1,1, and tritium is also an isotope of hydrogen, which is hydrogen 1,3. When they fuse into each other, they make the nucleus of helium, and that is helium 2,4. The process of nuclear fusion releases energy. The energy is released in the form of heat and light. So remember these words. So the exam tips here, they are when you are answering questions about nuclear fusion, remember it is only the nuclei which combine. Do not write about atoms. Okay, so use the word the nucleus of hydrogen, the nucleus of hydrogen, the nucleus of protium, the nucleus of tritium. They fuse into each other, they make the nucleus of helium. So this literature is written by Katie. Okay, the formation of the new elements. So when they fuse into each other, they make new elements, and the heavier nucleus form, they fuse into each other to make a more heavier nucleus. So let's see here. The formation of the new elements. During the majority of a star's lifetime, hydrogen nuclei fuse together to form helium nuclei. As the star runs out of hydrogen, other fusion reactions take place, forming the nuclei of other elements. For example, two helium nuclei produced by fusion of two hydrogen nuclei could fuse together to form a beryllium nucleus. So here you can see two helium nuclei, they will fuse into each other and they will make beryllium. Two helium nuclei fusing together to form a beryllium nucleus. The beryllium nucleus could then fuse with a helium nucleus to form a carbon nucleus. So beryllium and the helium, they will join together and they will make carbon. So you see what we have learned here. Hydrogen fuse, they make helium fuse with each other, they make beryllium and helium fuse with each other and they make carbon, and carbon is the basic element for the life. Elements lighter than iron are formed in the fusion reactions like the ones above. So I hope you understand. The formation of elements heavier than iron. Elements heavier than iron are produced in supernova explosions. A supernova occurs at the end of a massive star's life, when a star is dying. So a supernova takes place. So the heavier elements, which are heavier than iron, they are produced in supernova explosion. So when the star explodes, it releases very large amount of energy and neutrons. All of the elements which have been produced by the fusion reactions get thrown out and combine with the neutrons to form heavier elements. This literature is written by Miss Katie. I am sorry if I'm pronouncing her name. Maybe I pronounced the name in a wrong manner. So I'm sorry for that. The life cycle of a solar mass star is a very, very important question. The formation of the stars, nebula. So that's the life cycle, how this is born, and the life, different stages in the life of a star. So first one is nebula. Nebula is a cloud of dust and gases. Nebula, all stars form from a giant cloud of hydrogen gas and dust called a nebula. So then we have a protostar. The process of gravity within a nebula pulls the particles closer together until it forms a hot ball of gas known as a protostar. As the particles are pulled closer together, the density of the protostar will increase. This will result in more frequent collisions between the particles, which causes the temperature to increase. So then we have a main sequence. The first stage of the life of a star is nebula. Then we have protostar, and then we have the stage which we call main sequence of the star. Once the protostar becomes hot enough, nuclear fusion reaction occurs within its core. The hydrogen nuclei will fuse to form helium nuclei. Every fusion reaction releases heat and light energy, which keeps the core hot. So the life cycle of stars, once a protostar is formed, its life cycle will depend on its mass. The very massive star, from here, the life cycle is from very massive stars is different. And for the stars who are of the mass like our sun, their life cycle is little different. The different life cycles are shown below. So here we have So we have stellar nebula, then we have protostar, then we have the main sequence star. So then you have the stars about the same size of the sun. So they will, in the end, they will become red giant star, and then there will be a planetary nebula. So the stars which are big in mass, they will go from main sequence, they will go stars much bigger than the sun. We called it red supergiant star. And then supernova. After the supernova, they might go make a neutron star, or they might make a black hole. So let me show you, make the diagram bigger. So flow diagram showing the life cycle of a star, which is the same size as the sun, solar mass, and a life cycle of a star, which is much bigger than the sun. So this question is very, very important, in which we talk about the life cycle of the sun. Stellar nebula, protostar, then we have the main sequence star. Then there are different stages for the stars which are of the same size as our sun, and there's a different life cycle for the stars who has a very huge mass than our. So for the stars the same size as the sun, they will convert into the red giant star, then they will form the planetary nebula, and then they will convert into white dwarf, and then they will convert into black dwarf. Okay, so very large stars after the main sequence, they will convert into the red supergiant star, then into the supernova will happen. They will convert into the neutron star, or they will convert into the black hole. So this is the life cycle, and let me show you, let me reduce the size. So now you can see the whole cycle for both kind of stars together. So the life cycle for the solar mass star whose mass is approximately to same as the mass of our sun. Once a star is born, it is known as a main sequence star. Main sequence star. Okay. So remember, so during the main sequence, the star is in equilibrium and said to be stable. The inward force due to gravity is equal to the outward pressure force from the fusion reaction. Red giant. So the solar mass stars, they will, after the main sequence, they will convert into the red giant. After several billion years, the hydrogen causing the fusion reaction in the stars will begin to run out. Once this happens, the fusion reactions in the core will start to die down. This causes the core to shrink and heat up. The core will shrink because the inward force due to gravity will become greater than the outward force due to the pressure of the expanding gases as the fusion dies down. A new series of reactions will then occur around the core. For example, helium nuclei will undergo fusion to form beryllium. These reactions will cause the outer part of the star to expand. It will become a red giant. It is a red giant because the outer surface starts to cool. So then we have the planetary nebula. Once this second stage of the fusion reactions have finished, the star will become unstable and eject the outer layer of dust and gas. This layer of dust and gas which is ejected is called planetary nebula. Very important these literatures are. White dwarf. The core which is left behind will collapse completely due to the pull of gravity, and the star will become a white dwarf. The white dwarf will be cooling down, and as a result, the amount of energy it emits will decrease. So the black dwarf, once the star has lost a significant amount of energy, it becomes a black dwarf. It will continue to cool until it eventually disappears from the sight. So very important sequence. So here we have again, so you can see we have the, okay. So this is the life cycle of the solar mass star. A stellar nebula converts into the protostar converts into the main sequence star, the main sequence star converts into the red giant converts into the planetary nebula will convert into the white dwarf, and the white dwarf will convert into the black dwarf. So this is the life cycle of a solar mass star. So here we have the exam tips. So the exam tips are the term nebula is in the term nebula in astronomy refers to any cloud of gas or dust. The nebulae that form stars are made from hydrogen, whilst the ones that are formed when stars die, planetary nebula, are made from much heavier elements such as helium. Remember that the life cycle of a solar mass star starts when it is a nebula up till a black dwarf. You need to learn each step, but the life cycle is also slightly different for a star that is larger than our sun. This literature is written by Katie. So this all the literature is coming from her. The life cycle of a larger star. So the larger star whose mass is quite large, larger than our sun. A larger star is one which is bigger than the sun. Stars that are larger than the sun have much shorter lifespans in the region of hundreds of millions of years instead of billions. So their life is only in millions. So the other stars, their life is billions. Like our star, sun, its life is in billions of years. This is because they burn through the fuel in a nuclear fusion much quicker than the smaller stars. The life cycle of a star bigger than the sun starts in the same way as a solar mass star. So first step is nebula. So all stars form from a giant cloud of hydrogen gas and dust called a nebula. Protostar. The force of gravity within a nebula pulls the particles closer together until it forms a hot ball of gas known as a protostar. As the particles are pulled closer together, the density of the protostar will increase. This will result in more frequent collisions between the particles, which causes the temperature to increase. After the protostar comes the main sequence star. That's the third step of the life of a large star. So once the protostar becomes hot enough, nuclear fusion reaction occurs within its core. The hydrogen nuclei will fuse to form helium nuclei. Every fusion reaction releases heat and light energy, which keeps the core hot. Then, in the life cycle of a big star, comes the stage which we call that after the main sequence star comes the stage which we call red supergiant. Eventually, the main sequence star will reach a stage when it starts to run out of hydrogen gas in its core. Once this happens, the fusion reactions in the core will start to die down. This causes the core to shrink and heat up. The core will shrink because the inward force due to gravity is greater than the outward force due to the pressure of the expanding gases. A new series of fusion reactions will then occur around the core. For example, helium nuclei will undergo fusion to form beryllium. These fusion reactions will cause the outer part of the star to expand and it will become a super red giant. A super red giant is much larger than a red giant. After the super red giant comes the cycle stage in the life of a star, which we call supernova. Once the fusion reaction inside the red supergiant finally finished, The core of the star will collapse suddenly, causing a gigantic explosion. This is called a supernova. At the center of this explosion, a dense body called a neutron star will form. The outer remnants of the star will be ejected into space during the supernova explosion, forming a planetary nebula. Then we will have a neutron star or a black hole. In the case of the biggest stars, the neutron star that forms at the center will continue to collapse under the force of gravity until it forms a black hole. A black hole is an extremely dense point in space that not even light can escape from. So these are the life cycle, the stages, the 6 stages of the very big stars. So let me show you. So here we have the life cycle of a star much larger than our sun. So at the start, we have the stellar nebula, then we will have a protostar, then we will have the main sequence star, then that will convert into the red supergiant star, then the supernova will happen, and a neutron star will be formed, and at the end, you will get a black hole. That's the life cycle of a star much larger than our sun. So here we have the supernova. So here we have supernova. Supernova is a bright and powerful explosion that happens at the end of a massive star's life. It occurs when the star is bigger than the sun. The explosion releases a large amount of energy. During a supernova, all of the elements which were produced by the fusion reaction are exploded out along with neutrons. The neutrons combine with the elements to form even heavier elements. These elements are ejected into the universe by the supernova explosion and form the new planets and stars. Since Earth contains many heavy elements up to iron, this is a proof that it must have once been made from the remains of a supernova. So here we have a photo of the supernova. So you can see that the material is getting out of this supernova, it's being ejected into the air. So, my dear students, this literature is, I have taken this literature from the Save My Exam, and the author of this literature is Miss Katie. Katie or Katie. So, this remarkable literature is written by her. So we have circular orbits, orbital motion. There are many orbiting objects in our solar system. They each orbit a different type of planetary body. So here we have a table. So from this table, I can tell you that the orbiting objects or bodies in our solar system, and body or object and what it orbits. Okay, so for example, we have planets, and the planets, they are orbiting the sun. We have moon, and the moons are orbiting around their planet or planets. The comets, they orbit the sun. Asteroids, they orbit the sun. Artificial satellites, they orbit any object or body in our solar system. So the artificial satellites, sometimes they are orbiting around the Earth, and some artificial satellites, they are orbiting around the sun. So, or some other objects. A smaller body or object which orbits a larger body, in order to orbit a body such as a star or a planet, there has to be a force pulling things towards that body. So the gravity provides that force. The gravitational force exerted by the larger body on the orbiting body object is always attractive. Therefore, the gravitational force always acts towards the center of the larger body. The gravitational force is the centripetal force, as it will cause the body to move and maintain in a circular path. So here we have the gravitational, you can say what I can, here we go. The gravitational attraction causes the moon to orbit around the earth. Okay, so this is the earth, and there we have the moon. The moon is orbiting around the earth, so the gravitational attraction is towards the earth. Circular motion in an orbit. The planets travel around the sun in orbits that are approximately circular. Objects in circular orbits are traveling at a constant speed. The orbits in a circular path, the orbit in a circular path, therefore, the direction in which the object is traveling will be constantly changing direction. A change in direction causes a change in velocity. Acceleration is the rate of change of velocity. Therefore, if the object is constantly changing direction, then its velocity is constantly changing. So the object is in orbit is accelerating. A resultant force is needed to cause an acceleration. This resultant force is gravity, and it must act at right angles to the instantaneous velocity of the object to create a circular orbit. This is always towards the center of the orbit. The instantaneous velocity of the object is the velocity at a given time. Okay, so here we have a diagram which show you. Acha. So here we have the sun, here we have the earth. So when the earth is here, its instantaneous velocity is along this tangent. When the earth is here, its instantaneous velocity is along the tangent at that point. So, but the direction of the gravitational force is always towards the sun. The direction of the gravitational force is towards the sun. The direction of the instantaneous velocity and the gravitational force at different points of the Earth's orbit around the sun. So here we have some exam tip. When you are describing the motion of an object in orbit, make sure you describe the correct terminology. Speed is a scalar quantity. It has a magnitude, which means size only, and the velocity is a vector quantity. It has both a magnitude, which means size, and a direction. So then we have the circular orbits. Planets, there are several similarities in the way different planets orbit the sun. So the similarity between them is their orbits are all slightly elliptical, stretched circles, you can say, with the sun at one focus, approximately the center of the orbit. They all orbit in the same plane. They all travel the same direction around the sun. There are also a few differences. They orbit at different distances from the sun. They orbit at different speeds. They all take different amount of time to orbit the sun. This is a very famous question. The similarities and differences in the circular orbits. So here we have another diagram. So it says the orbits of the planets around the sun. So this is sun. These are the orbits. So they are moving anti-clockwise. So the planets furthest from the sun takes the longest amount of time to orbit the sun. They travel at the slowest speed. The planets closest to the sun takes the shortest amount of time to orbit the sun. They travel at the fastest speeds. Remember this diagram. So here we have, we talk about the moons. The moons will orbit planets in a circular path. Some planets will have more than one moon. The closer the moon is to the planet, the shorter the time it will take to orbit, the greater the speed in the orbit. Artificial satellites. A satellite needs to travel at a specific speed to maintain a circular orbit at a particular distance from the object. If the speed of the satellite is too big, the radius of the orbit will increase and the satellite will spiral into space. This is because the gravitational attraction cannot provide enough force to keep it in the orbit. If the speed of the satellite is too small, the radius of the orbit will decrease and the satellite will move towards the object it should be orbiting. This is because the gravitational attraction is too strong to maintain a constant orbital radius. So here we have a diagram showing how the speed of an artificial satellite affects its orbit. Satellite does not have enough speed to reach a circular orbit, so that satellite is going to collapse into the Earth. And the satellite is traveling at the correct speed to reach a circular orbit. So if the speed is correct, uh, they will keep on rotating at a certain height around the Earth. The satellite is traveling too fast to reach a circular orbit. So if the speed is too large, so the satellite will go into the space by making a spiral path. So in an artificial satellite, to change the radius at which it is orbiting, then the speed at which it is traveling must change. To maintain a stable orbit, if the speed increases, the radius must increase. If the speed decreases, the radius must decrease. So this literature is written by Miss Katie. Okay, so we have orbits of a comet. The orbits of a comet are very different to those of the planets. The orbits are highly elliptical, very stretched circles, or hyperbolic. This causes the speed of the comets to change significantly as its distance from the sun changes. Not all comets orbit in the same plane as the planets, and some don't even orbit in the same direction. Okay, so you can see this shape. This is the orbital path of a comet. So you can see this is called elliptical, this point, and this point is called the focus of the elliptical. So the sun is on one of the focuses of this elliptical orbit. So when the comet is near the sun, it becomes fastest. When the comet is furthest from the sun, its speed becomes slowest. So when the comet comes near the sun, its ice melts, and that's why it makes a tail. And so this is the orbital path of a comet. Okay. As the comet approaches the sun, it loses gravitational potential energy and gains kinetic energy. This causes the comet to speed up. This increase in the speed causes a slingshot effect, and the body will be flung back out into space again, having passed around the sun. As it moves away from the sun, the body will slow down, eventually finishing its orbit and falling back into towards the sun once more. In this way, a stable orbit is formed. So remember, this literature is written by Miss Katie. And I have taken this literature from the website Save My Exam. So we have galactic redshift. So galactic redshift, usually when an object emits waves, the wavefronts spread out symmetrically. If the wave source moves, the waves can become squashed together or stretched out. For example, you can see, let me show you this diagram. So this drawing is showing the wavefronts produced from a stationary object and a moving object. From, for example, if the car is stationary, so the waves produced by the sound which is produced by this car are equally spaced. Okay. So, but if the car is moving in towards the right, so and it's producing some sound, so if you are observing that sound waves here, so you will observe that their wavelength will become less because the car is approaching you. But you observe those same sound waves as by standing here, you will observe that their wavelength has increased. The moving The moving object will cause the wavelength lambda and frequency of the waves to change. The wavelength of the waves in front of the source decreases and the frequency increases. The wavelength behind the source increases and the frequency decreases. This effect is known as Doppler effect. The Doppler effect also affects light. If an object moves towards an observer, the wavelength of the light decreases. This is known as blue shift, as the light moves towards the blue end of the spectrum. If an object moves away from an observer, the wavelength of the light increases. This is known as redshift, as the light moves towards the red end of the spectrum. So, if you are observing a star and the star is moving towards you, then it will have a blue shift. If the star is moving away from you, then it will have a red shift. So here we have, it says the light from a star that is moving towards an observer will be blue shifted, and the light from a star moving away from an observer will be red shifted. So an object which is not moving relative to the observer, so in all the directions, the wavefronts, the wavelength will be same. But for example, the source is here and the source is moving towards the observer, then it will have a blue shift. The frequency will be higher. If the source of the waves is moving away from the observer, and then the observer will observe a red shift, and it will have the frequency which it will be receiving will be lower frequency than the actual frequency produced by the source. So direction of the motion, observer and the observer in front observes a blue shift. The observer behind the source observes a red shift. Because here the source is coming towards this observer, so it will have a blue shift. Because here the source of the waves is going away from the observer. So here when you will observe these waves, it will have a red shift and they will have less frequency. So here we have some exam tips, and the exam tip is you need to know that in the visible light spectrum, red light has the longest wavelength and the smallest frequency. To help you to remember what happens to the wavelength and the frequency of an object as it moves further away, it is useful to think about how the sound of a motorbike would change as it travels past and then away from you. As the motorbike moves away from you, the pitch of the sound will become lower. This means the frequency of the sound is decreasing. If the frequency has decreased, the wavelength must also have increased, the opposite. Okay, the opposite will be happening. So here we have the expanding universe. The diagram below shows the light coming to us from a close object, such as the sun, and the light coming to us from a distant galaxy. So here we have the light spectrum from a close object, such as the sun, and this is the light spectrum from a distant galaxy. So you see these bands, they have moved towards the, so this portion has moved little this way. So look at these black lines, okay? So these two black lines are here, but here they are further towards the red. If you look at this line is here, but here the line is here. This line was here, but it has moved here. This line was here, but now it has moved here. So these lines, this is the spectrum from the sun, and this is the spectrum from the distant galaxy. So the lines have moved towards the red. So that means that that galaxy is going away, okay? Because the pattern has moved towards the red. So it has a red shift. The diagram below shows the light coming to us from a close object such as the sun and the light coming to us from a distant galaxy. Comparing the light spectrum produced from the sun and a distant galaxy, I can tell you that the galaxy is moving away from you because it has a redshift in it. The diagram also shows that the light coming to us from distant galaxies is redshifted. The lines on the spectrum are shifted towards the red end. This indicates that the galaxies are moving away from us. If the galaxies are moving away from us, it means that the universe is expanding. The observation of redshift from distant galaxies supports the Big Bang theory. Another observation from looking at the light spectrum produced from distant galaxies is that the greater the distance to the galaxy, the greater the redshift. This means that the further away a galaxy, the faster it is moving away from us. So here we have so graph showing the greater the distance to a galaxy, the greater is the redshift and the greater is the speed which the galaxy is going away. So you can see from here, this graph, here we have the redshift, here we have distance. The greater is the distance, the greater is the redshift. The author of this literature is Miss Katie or Cathy, you can say. And then we have the Big Bang theory. Around 40 billion years ago, around 40 billion years ago, the universe began from a very small region that was extremely hot and dense. Then there were a series of explosions, which we call the Big Bang. This caused the universe to expand, cooling as it does so, to form the universe we currently observe. Each point expands away from the others. This is seen from galaxies moving away from each other, and the further away they are, the faster they move. As a result of the initial explosions, the universe continues to expand. So here we have a diagram. We reduce the size. Okay. So all galaxies moving away from each other, indicating that the universe is expanding. So all the galaxies are going away from each other. So evidence for the Big Bang. Okay. So by observing the light spectrum from supernova in other galaxies, there is evidence to suggest that distant galaxies are receding, which means moving further apart, even faster. These observations were first made in 1998. The light spectrums show that light from distant galaxies is redshifted, which is evidence that the universe is expanding, the galaxies are moving away from us, and indeed each other. This is what happens in an explosion. Matter is first densely packed, and as it explodes, it moves out in all directions, getting further and further from the source of the explosion. Some matter will be lighter and travel at a greater speed further from the source of the explosion. Some matter will be heavier and travel at a slower speed closer to the source of explosion. If you were to travel back in time and compare the separation distance of the galaxies, they would become closer and closer together until the entire universe was a single point. If the galaxies were originally all grouped together at a single point and were then exploded, we would see a similar effect. The galaxies that are moving fastest would move the furthest. The distance they move would be proportional to their speed. The galaxies that are moving slowest would move the least. This literature is written by Katie or Katie. Okay, so we have the dark energy and dark matter. Dark energy and dark matter. Over the past 2 or 3 decades, astronomers have gathered plenty of evidence helping us to understand the universe much better. However, there are still many observations that are still not understood, including evidence from the rotation and motion of galaxies suggests that there is much more matter in the universe than we are able to account for. This unseen matter is given the name dark matter, and its nature is not currently known. Measurements of the expansions of the universe using supernova suggest that the universe is starting to expand at a faster rate. It has been suggested that this accelerated motion is caused by dark energy pushing everything in the universe apart. If gravity is present everywhere in the universe, it might be expected that everything will one day become closer together. But that is the opposite of what we see. This is another reason why dark energy is possible solution, which could be contracting gravity and expanding the universe instead. This literature is written by Miss Katie or Katie. So, my dear students, we have reached the end of this. This was a source which was available to revise the topic, the space physics. And I have downloaded this whole literature from the website Save My Exam. And this literature is written by Miss Katie. And I thought that this can be a useful thing for my students all around the world to revise the space physics. I have made videos from 2 different books already on the space physics, and they are very detailed videos. I suggest that you watch those videos and you watch this video also to revise the space physics topic, because this is a new topic. We don't have questions on this topic. So the more and more literature you study, the better you will be prepared to answer the questions. So thank you very much for watching this. I will suggest that watch more and more videos on the space physics that will help you to master this concept. So thank you very much for watching this video and taking out time and showing the zeal to learn more and more about the space physics. So thank you very much. Have a good day and God bless you all.